Good morning, all.
Good morning, sir.
So, in the last class, we have discussed about the coke making process. In fact, in last few classes, we were discussing about coke making process through both non-recovery as well as byproduct coke oven process. So, in today's session, we will see whatever the coke we have produced by both the processes. So before you subject this coke as a feed material into the blast furnace, we should assess the quality of the coke. That is most important. So this quality of the coke is influenced by the grade of the coal, what we have used for the preparation of the coke. Grade of the coal means its type and rank of the coal, which governs the selection of a coal in terms of how it will behave during the carbonization process. As I mentioned previously, that all coals does not subject for the coke making process. Only few coals which undergo physical changes along with the chemical changes. So those coals only we can subject for the coke making process. So the coke which is suitable for the blast furnace operation should have some peculiar properties. So the coke should have a sufficient strength. It should have sufficient resistance to abrasion. It should withstand the pressure which is exerted by the burden. It should be highly reactive when it is undergoing combustion process. So these are some of the qualities the coke should have before we subject into the blast furnace. So today we are going to discuss what are the various testings which we do on the coke to evaluate its quality. The first testing, that is the coke strength. The coke strength is very important for its use in metallurgical furnaces. The coke, whatever it is prepared in the coke ovens, that will be transported through the conveyor belts and is stored and is charged inside the furnace. So in all these stages, during its transportation, during its storage, during its charging into the furnace, in all these stages, it should not lose its shape. It should retain its shape and dimensions. It should not generate fines. Generation of high amount of fines is not desirable for a smooth working of the blast furnace because it hampers the permeability of the lead inside the furnace. Right. So the generation of the fines can take place either due to impact or due to the wear which takes place during the its traveling inside the furnace, because inside the furnace it's a continuous moving burden from top to the bottom. So during its motion, there is a very high possibility that uh, there could be abrasion may take place between the particles, because we are using different kinds of raw materials with different uh, size and shape. So when it is under motion, so all these raw materials will mix together, and certainly there will be an abrasion may take place between the particles that may lead to generation of the fines. So to evaluate impact strength and abrasion resistance of the coke, so we are going to perform the shatter test, which will give an idea about the impact strength of coke. So this test consisting of a steel box, open top and drop bottom, and you have a base plate, one with the locking latch, and in the middle of to be held as a closed or drop open position. This box is fitted at a height of 2 meters above the base plate, made of a thick sheet. You can see that this entire setup in this particular picture. This is the box, and these are the openings. Initially, when you are filling coke, it will be in a closed condition. These two halves will be in a closed condition. But when you are releasing it, this will be opened, and the coke will fall down from a height of around 2 meters. And here at the bottom, you have a collecting tray will be there. So if you see the procedure for this test, we need to take a sample size of 22.7 kg of plus 50 mm size coke particles, and it is dropped 4 times from a height of 2 meters on a steel plate. And after that, we need to collect the entire sample, which is settled on the steel plate, and need to arrange the sieves of size 50 mm, 37 mm, 25 mm, and 12 mm. And then we need to do the screening, and we can find it out the shatter index test, shatter index of the particular coke by using this particular formula. That is the weight of the coke surviving bigger than 50 mm divided by the total amount of coke into 100. So this will give. So you need to arrange the sieves as per this series, as per this sequence. The finest will be at the bottom. So at the bottom you have 12 mm, then you have 25 mm, then you have 35 mm, then at the top most you have 50 mm. And we need to see the weight of the coke surviving on the 50 mm sieve. That weight we need to take divided by the total amount, that is 22.7 kg. into 100. So this will give the starter index percentage. And now next one is the MyCum drum test, or you can say tumbler test. So this will give an idea about the coke which having resistant to impact and abrasion. In this method, we are taking 50 kg of coke sample, which is having the size of -75 to +50 mm. That means we need to first take the 50 mm size sieve and 75 mm size sieve, and we need to do the sieving, and we need to collect the coke samples having size range greater than 50 and less than 75 mm. So that size range particles of 50 kg, we need to first collect it, and we need to weigh it, and then the weighed amount of coke sample that we need to subject into the MyCum drum, having dimensions of 100 mm dia and 1000 mm dia and 1000 mm wide, and we need to allow this drum to rotate for 100 revolutions at an RPM of 25. After that, we need to collect the sample from the drum, and we need to do the again sieving by using different screens. So here again we are taking screens of 60 mm, 40 mm, 20 mm, and 10 mm aligned in the same manner, and we need to do the sieving, and we can find it out the M40 and M10, which represents the resistance to impact and resistance to abrasion. The M40 can be calculated by using this particular formula, that is weight of the coke retained on 40 mm screen divided by the initial weight of the coke, whatever you have taken, that's 50 kg into 100. Similarly, M10, that we can calculate by using this particular formula, that is weight of the coke passing through 10 mm screen, that is -10 mm. The amount of coke which is passed through 10 mm screen divided by the initial weight of the coke into 100. So this will give the M10. So the percentage of coke retained on the 40 mm screen and that passing through the 10 mm screen are designated as the MyCum indices, M40 and M10. The higher value of M40 indicates good resistance to impact, while higher value of M10 indicates poor resistance to abrasion. So for charging coke in a blast furnace, the desirable properties are coke should have high M40 and low M10. Values. So this will the desired properties of the coke. Means whatever the value you will get here, suppose if you have if you get a high value of M40 and a low value of M10, so that is most desirable. As per the Indian standards, the minimum M40 index should be 75%, Means the value what we need to get here should be minimum 75. And here it should be not more than 14%. If this value is becoming high, that means your coke is having poor abrasion resistance. So if you consider blast furnace is having 2000 meter cube working volume, then the coke, whatever you are going to charge as a fuel inside the blast furnace, it should have M40 more than 78 and M10 should be less than 10. The next one is coke strength after reaction and coke reactivity. Coke reactivity is a measure of the rate at which the coke carbon which is present in the coke reacts with the oxidizing gases in like carbon dioxide or oxygen or steam in front of the tuyeres. So in front of the tuyeres, coke undergo combustion. So the rate of the reaction depends upon the characteristics of the coke surface, the total surface area of the coke exposed, and the gas composition which is prevailing in front of the tuyeres, its velocity, and its temperature. The reactivity of the coke has a direct relationship with the resistance that coke offers to CO2 attack. That is called as solution loss reaction, where there is a loss in the carbon by this particular reaction, that C plus CO2 gives rise to 2CO. So this is basically an endothermic reaction. So if this occurs on the surface of the coke particles inside the blast furnace, then there will be a huge temperature gradient occurs in the coke particle from the center to the surface, which leads to the thermal crack or thermal stresses within the coke particles. That will certainly lead to generation of the fine fiber. If the coke does not have good strength, high temperature, so due to thermal stresses caused by the solution loss reaction, so the coke certainly will undergo fragmentation. So too high a reactivity will lead to high solution loss, thereby giving some of the disadvantages. That is, there will be loss of carbon from the stack region of the blast furnace, resulting in high coke rate. There could be degradation of coke owing to the gas produced in the solution loss reaction. There could be decrease in the hot strength of the coke after reaction. There could be a reduction in the size of the coke in the lower part of the furnace. Then effect on the permeability of the coke bed in the furnace hearth. These are some of the consequences which may lead in the blast furnace. So Nippon Steel Corporation of Japan, they have developed a method to test the reactivity of coke, that is your CRI, coke reactivity index. along with coke strength after reaction, that is CSR. So the procedure for the CRI and CSR are, we need to take 200 grams of 20 mm coke in a tube, and we have to allow it to react with the CO2 gas, flow rate of 5 liters per minute for 2 hours, keeping a temperature of 1100 degrees centigrade. And after that, left this material for cooling, and then you wait, and then you can calculate what is the coke reactivity index. So that can be calculated by this particular formula. So weight loss method, original weight minus weight of the residue by original weight into 100. So this will give the coke reactivity index. Similarly, for finding out CSR, that is coke strength after reaction, leftover coke means after cooling, that you can collect it and you can feed that into a drum, just like a ball drum of 130 mm dia and 700 mm long, and it is revolved for 30 minutes at 20 rpm speed. And then you collect the sample and you receive that particular material using 10 mm screen, and then you can find it out what is the coke strength after reaction by using this particular formula. That is weight of the coke residing on 10 mm screen after this ball milling by weight of the initial sample into 100. So this will give the percentage of CSR is coke strength after reaction. So these are the some of the tests we need to perform, find out the properties of the coke before we subject into the blast furnace as a feed material. So a minimum CSR value of 60 and a maximum CRI of 28 are considered desirable for high quality coke which can use in the blast furnace. As far as the Indian blast furnace is concerned, CSR, that is the coke strength after reaction, it should be about 60 to 65%, and CRA is of around 25%. So that could be the better for the Indian scenario. And then finally, the functions of the coke. So what is the role of coke inside the blast furnace? Coke plays a major role inside the blast furnace. It is a fuel providing heat for meeting the required temperatures inside the blast furnace. Because blast furnace iron making process is a complex reactor where you'll be having a lot of endothermic, exothermic reactions takes place. So the amount of heat required for the reactions to take place will be supplied through the fuel. Not only that, to melt the slag or metal, this the carbon is represented in the coke will be very much helpful. It produces and regenerates reducing gases for the reduction of iron oxides. It provides an arable bed inside the blast furnace through which liquid products, whether it can be hot metal as well as slag, can easily trickle down to the bed of solids, and finally it will get collected in the hard part of the blast furnace. It allows passage for not only the liquid products in the downward direction inside the blast furnace, but also coke slits will allow the reducing gases to pass through in the upward direction. So this will coke slits will allow these counter current reactions to take place effectively inside the blast furnace. It allows the passage for both reducing gases as well as the liquid products in the counter current in the opposite directions. So it supports the entire burden overlying on it inside the blast furnace. It also carburizes the iron, thereby we could able to tap the hot metal at very low temperatures below its melting point. So these are some of the functions of the coke inside the blast furnace. With this, the first module is finished, where we could able to discuss the concepts related to what is the historical scenario of iron making process, how the iron making process has evolved over the decades. And we also discussed about what are the various raw materials which we use inside the blast furnace, its characteristics. We also discussed about the availability of these raw materials in India, where it is located, how much quantity it is available. We also discussed about various integrated and steel plants, both located in India, both in a public and private sector, and its contribution in terms of production, as well as what kind of products they are producing. And we also discussed about the ores of iron, what are the different kinds of ores which are available, and its properties. And we also discussed about coal formation, and then beneficiation process for the coal. And then we discussed about what are the testings we basically do for the coal before we subject for the coke making process. And then we discussed about how the coke is prepared in the ovens, how the coke making process have evolved, starting with the heave kind of a coke ovens, and then then it is abandoned, and it leads to the evolution of non-recovery coke ovens, and then you have byproduct coke ovens. We also discussed about how the coke is prepared through a non-recovery coke oven process, as well as byproduct coke oven process, followed by what are the various testings which we basically do for the coke before we subject it into the blast furnace. So this is all about first module. So in the next class, we will discuss about the module number 2, which will discuss about the other raw materials and its preparation. Thank you.